So we're gonna do a proof of the law of cosines. So that the law of cosine says that if you have a triangle A, B, and C, and you know three of these, then you can find either a side, or an angle, or another side. So you just need three of these in order to find the last. So this one's gonna be alpha here because it's across from side A. So the law of cosines for this one would say that a squared is equal to b squared plus c squared minus 2bc cosine of alpha. Okay, so let's see how that turns out. Okay, so first we're gonna make this into a right triangle. That looks like a right triangle. And then we're gonna say that this side right here is x. This side right here is y. And this side over here is gonna be z. Okay, so let's write down some equations. So we know that x plus y is equal to c. We also know that x squared times z squared is equal to b squared. So we can write that down. We also know that y squared plus z squared is equal to a squared. And we need to include the angle in one of our formulas. So the cosine of alpha is equal to adjacent over hypotenuse. So I'll write that here. Cosine of alpha is equal to adjacent over hypotenuse b. Okay, so the first thing that I'm gonna do is I'm gonna isolate x here. So I'm gonna do multiply both sides by b times b. And cancel this one out. So we end up with x is equal to b cosine of theta, cosine of alpha. Okay, and alright, so now I'm gonna take okay, so I'm gonna equal these two equations to each other. So both of them have z squared. So I'm gonna get z squared by itself for both of these equations. So here, I'm gonna move this over here. So I have some space. And I'm gonna do minus x squared, minus x squared. So that's gonna cancel these two out. So I'm gonna end up with z squared is equal to b squared minus x squared. Okay, so I'm going to do something similar in the equation on the right. And so we have minus y squared minus y squared. So that cancels these two out. And we end up with z squared is equal to a squared minus y squared. Okay, so now I can equal these two equations to one another because both of them equal to z squared. So I have, so combining them together, I'm gonna do it in the middle here. So I'm gonna have b squared minus x squared is equal to a squared minus y squared. And that's because both of these are equal to z squared. So that means they're equal to one another. Okay. So now, let's see. So it looks like we can replace the x, so substitute it into here. So instead of having an x, I'm gonna put b cosine alpha. So I have b squared minus b cosine alpha. that's going to be squared is equal to, here, let me move it so it looks the same. A squared minus y squared. Now what I'm going to do is I'm going to substitute this into this x here, and then I'm going to isolate y. So let me write down the equations that I have. So I have equation 1, I have equation 2, I have equation 3, which I combine with equation number 4. So that's what I have over here. And now I'm substituting equation 2. So the next step was I substituted equation 2 into here. But I'm also going to substitute equation 2 into equation 1, which I'm then going to substitute into equation, let's call this equation over here 5, because it's this is a mix of equation 3 plus 4, and then let's call this equation 6, which is a mix of equation 3 plus 2 plus 1, 2, 3, and 4. And now I'm going to combine equations 2 and equation 1. Okay, so I'm going to do that over here. It's like a separate equation 7. So I'm going to take this and plug it into this x over here. So now I have b cosine of alpha plus y is equal to c. So I've just replaced the x here with b cosine of alpha. So this is going to be a mixture of equation 1 plus equation 2. And now I'm going to isolate y. So minus b cosine of alpha minus b cosine of alpha. So this cancels out. And now I have y is equal to c minus b cosine of alpha. Okay, so now I'm gonna take equation 7 and I'm gonna plug it into equation 6. Okay, so I have like equation 8 over here. I'm gonna call it equation 8, which is gonna be a mixture of 2 plus 3 plus 4 plus 7. And so what I'm gonna do is I'm gonna substitute this for the y over here. So now I'm gonna have b squared, so I'm just copying this down from this equation, minus b cosine of alpha squared is equal to, now I'm gonna run out of space here, so I'm gonna move some stuff around. So I'm gonna put this down here. But again, I'm just copying down things from this equation here. So a squared minus, now I'm substituting equation 7 goes into the y here. So I'm going to have c minus b cosine of alpha in parentheses squared. So I just took the y is equal to c minus b cosine alpha, and I substituted it in here, so that's in here. So that's this entire thing. It used to be y, now it's just c minus b cosine alpha squared. Alright, so from here we should be able to get the law of cosines. So now let's make sure that it works. B squared minus b squared cosine of alpha squared. So we squared both the b and the cosine alpha. That's equal to a squared minus c. Oh, now we're going to have to FOIL this out. So let's separate it first. I'm just going to copy paste this here. I'm being lazy. Put it in there. Whoa. Okay. I have to squeeze it in there. Put it in here too. Okay. So now we FOIL. So first outside, inside, last. Okay, hopefully you guys know how to FOIL. And then, so we multiply these two numbers first. That's c squared. And then we're going to multiply c times b cosine alpha. That's going to be minus. I'm going to put parentheses around this because we're going to have to distribute that negative in front. Minus b c cosine alpha. And then inside, so we're going to do these two numbers. So that's going to be minus b cosine bc cosine alpha. And whoops, we're going to run out of room there. Move this over here. And the last numbers are b cosine alpha and b cosine alpha. So those are two negatives, so that makes a positive b cosine b squared cosine alpha squared. Okay, and we still have a negative in front here. That's this one right here. So we put an a squared over on this side, and then we just copy down the left portion of the equation. Okay, so now we're gonna distribute this negative across. But before we do that, let's combine like terms. These two are like terms. So we are gonna have negative 2 b cosine alpha, bc cosine alpha, plus, and we'll copy down the rest, b squared cosine squared alpha. But now we have to change, we're not changing anything yet. C squared. Okay, so we still have that negative, and then I'm just going to copy down the rest here. And then I'm going to distribute this negative sign to everything. So distribute that negative. Everything's going to get a negative over here. Okay. So negative c squared, that's going to be plus 2 bc cosine of alpha minus b squared cosine squared alpha and a squared. Okay, so now what I'm going to do, again, keep copying everything down here, is I'm going to add b squared cosine squared alpha to both sides. So when I add it to this side, well, that cancels that out. And since I added it to the other side as well, that canceled that out. Okay, so now all I have to do is move these two over. So plus c squared plus, and it's not like terms, so we'll just do plus c squared. And that cancels that out. So on the left side right now we have b squared plus c squared is equal to a squared. And then the only thing that's left is this plus 2 bc cosine alpha. And then now we just subtract 2 bc cosine alpha minus 2 bc cosine of alpha. And then that cancels out. And so we end up with a squared is equal to b squared plus c squared minus 2bc cosine of alpha. And we just need to flip it around, right? So like, let's put this on this side and this on the right side. It's the same, it's equivalent. And there's your law of cosines. So it's a big long mess just so that we can get to this bad boy over here at the top. So a squared is equal to b squared plus c squared, b squared plus c squared, minus 2bc cosine alpha, minus 2bc cosine alpha. Now this is the way that I did it, but there's another proof that you can do. uh, using the distance formula. But this is one way to do it. All right.